So just in review of these notes here, just a quick review, there's three things that are really important for you to distinguish between reflected sound, okay, reflect, that's literally when waves bounce off something. An echo, okay, a person that is calling out, okay, they're calling out, here's their sound waves. If they're, there's a big cliff here, their sound waves hit the cliff and they bounce back. That's an echo that you hear. So sound waves are bouncing. That's reflection. Okay. 11.9 in your textbook, we also talk about refraction. So reflection and refraction. Very important. They're different. Refraction is the bending of a wave. And that's due to the wave passing into a new medium. Because the speed of sound goes at a different rate. Okay? And the little example we used there was a wagon with 4 wheels. Right? As the wagon, here's the handle. As the wagon goes down the hill, this way, if you've got grass on the hill and then it hits a muddy patch, right? If this is mud right here, then what's going to happen is the wheels are going to slow down on this side, right? And so what's going to happen is the wagon's going to end up turning. Right? You've all kind of been in a wagon before. But it turns, and so what happens is you have a bend, right? And the wagon's going to bend because this wheel is slowing down. So the same happens with sound. That's a refraction. And same happens with light too, bending of light as well, and so on, but we're talking about sound this time. So reflection, refraction, and then the third one that's really important to notice is, this one here is diffraction. Okay? Diffraction is also the bending of a wave, but it's not because of a different medium, it's because of because it's traveling through some kind of opening. And here's your diagram here explaining diffraction. Sound wave comes in, and it sort of like hugs around the opening and causes it to bend a little bit. So reflection, refraction, and diffraction, very important to know the difference between those two. So diffraction also happens around corners, so not just openings, but around corners. What's important to note is that the longer the wavelength, the more it bends. Okay? So here's an interesting thing about sound. The high-pitch sound, okay, of an instrument like maybe a violin or a flute or something like that, the high-pitch sound, the frequency and the wavelength is, frequency is high, wavelength is pretty small. Higher pitch, okay, oh, it's a piccolo, I guess, in this diagram. But you see how this doesn't bend around corners as much as a big bass drum. Now the bass drum is a low pitch, it's a longer wavelength, and lower frequency, right? So the longer wavelengths basically get affected by these corners quite a bit more. And so this person over here, okay, would hear the bass drum as it diffracts around a corner before they would hear the high-pitch piccolo or the flute. Okay? So the longer wavelengths will bend around corners a bit better. And they'll also penetrate through material better too. That's why you hear the bass coming through, and coming through the walls and stuff like that. Okay? But that's why you hear the bass of a car or something like that, from far away, because that bass will travel, it'll bend, it'll penetrate. All right? So again, there's the notes there. This situation is why you can hear the thumping car bass for blocks away before you can hear the high-pitch frequencies. Okay? All right, so I'm going to direct you to 366 for a good review, and I'll also let you take down, now this is for the wrong semester here, so that due date obviously does not apply to you, not March. But take a look at page 366, and you can also then copy down Chapter 11 review questions, which I'll let you start working on here today. You can also look at page 369 for a review of the chapter. So that's Chapter 11 review points, or review notes. The chapter summary it's called. So that's also a good one to look through. And there are your Chapter 11 questions. You may start on that.